Yeah, I've known Emil since 2004 in a very strange situation. We went to an SE conference in the airport. I met him and we talked. And then it's time for him to board us there. I'm in the same airplane. So I went to the same airplane. I sat down right beside him. I said, wow, it's such a good coincidence. We have the same, our seats are so close to each other. But 2 minutes later, somebody called me. Said, Yong, please come to the attendance. I said, what happened? I went to a wrong airplane. So I always went to. So somehow in that meeting, so from that time, we know each other and we have been talking to each other. And they asked me to give a very fancy, appealing title of the presentation, so that will make people think. So I put up this title, and I start to think about it myself and my students too. But before that, yesterday when I came and I went to a few presentations, I learned many things. One discussion I had made with a few others in the evening events. We were discussing about what is design science. Is there a design science? How does a possible design science will look like? Because many people don't think it's possible, because design is such a diversified activity. It's arts design, engineering design, many different designs. It's possible to have a design science. But another thing, a question I heard is that, how do you use data to drive design? Just right now we talk about IoT. You get a lot of data, but how do we use the data to drive design? And what data? That's questions we have been asking. In many cases, those data are unstructured because it happens in our everyday life. It's in the field application. So how can we structure unstructured, uncontrolled data? And another thing, we talk about the trust, talk about many things. People talk about perception. So how does perception play a role in this IoT, in our daily design process? Let's come back to the title again. So I asked my students to prepare a draft for me. So then they came back with a few questions. The question asked me, what is being creative? So when we say, we want to have a brain to make it to be creative. So what is being creative? The second question they asked me, what is a rational brain? And then, what is an emotional brain? Finally, they asked, which brain contributes to our creativity the most? And how do they contribute to our creativity? So in answering those questions, we start to think ourselves. I hope you will, before I present our work, you will, I believe you must have been starting to think about these questions as well. So those questions, I think, is the objective of design science. We talk about what is design science? Is it possible to have a design science? I think those questions are one of those questions that the design science must answer. So in my talk, will be very different from the IoT. One IoT is very ground to the earth. Mine is very it's kind of a theoretical, but I hope this will going to trigger people to think. So then let's come to the first question: what is being creative? I think when you have this word, creative, I think many words will come to your mind. Creativity, firstly, is random. It doesn't happen in the way that you want it to happen. Sometimes you want yourself to be creative, but it doesn't happen in that way. And sometimes you don't expect it to happen to you. For some reason, we don't know. And there are many possibilities. There's all kinds of solutions, and it's unpredictable. And it needs a flexible environment. You have to have the freedom to be creative. Otherwise, it's impossible. So then, what is a rational brain? So when we say rationality, when we make a decision, we say a rational decision. What is a rationality? Rationality comes to our knowledge, comes to our logic. So our computer is the perfect example of a rationality. You have a step-by-step approach to solving a problem. So this is the rational part of our brain. People see we have the rational part of our brain. Then what is the emotions? So when we talk about creativity, people always think about arts, think about inspiration, think about stress, think about many, many other things. So it's an emotional part. So people have been, brain science, people have been studying the brain. So you have the left side brain, right side brain. So left side brain takes care of logic, rationality. And the right side takes care of creativity, emotions. So we will assume that right-hand side brain emotion will play a very important role in our creativity. So now we have to answer this question: how do these two brains contribute to our creativity in what way? So this comes to design science. So now let's go to some very fundamental part. So what is a science? So when we say it's impossible to have a design science, then what is science? We don't give a definition what is a science, and then we see, I went to dictionary, says science is a branch of knowledge or dealing with a body of facts or truths systematically arranged and showing the operation of general laws, which is gained through observation and experimentation. So this is not the perfect definition, but it's one of the definitions. But there's many few things there. From there, so firstly, it's a body of facts or truths about something, about the world. So this is the object of study. Secondly, it is a body of facts or truth. So we need to have a hypothesis or laws or something like this, axioms. Like Elon wants to build an axiom of fusion. I heard it yesterday, right? They're kind of a science to do that. Then for any science, we need to have a logical tool, reasoning tool to do that. And then we have to be able to do experiments to verify, to validate the hypothesis or theories from the science. So then let's look at the example of physics. What is physics? Dictionary says physics is a science that deals with matter, energy, motion, and force. So then we have all learned what is physics. You get all those symbols and you get the relationships. And in physics, we have Newton's three laws of motion. We have a reasoning tool, which is calculus. Then we do experiments to validate all those things. Then we have a full body of physics. Let's come back to design science. So what if we have such science, what design science should be? So I give a definition of design science. Design science must be a science that to interpret the phenomena in design by making discoveries. So we have to discover the regularities behind phenomena of design activities. So it must have 3 or 4 parts. Firstly, what is the object of study of design? Secondly, do we have some axioms behind the design activity? And then what are the reasoning tools to do that? Like right now in design science, what are reasoning tools? Natural language and flowcharts. We draw flowcharts to do that. Experimental tool, people now are starting to build up tools, experiment tools to do that. Let's look at the first one. What is the object of study? So I started with the definition of design, description of design. So simply, we have many ways to describe design. Intuitively, I can, if I say this is the definition of design, I don't think anyone is going to challenge that much. But you can always have different definitions. So design is an activity in which designers create the preliminary sketch or plans of an artifact intended for a purpose to serve its environment. But you can have many kinds of descriptions. This is not the perfect definition. This is just to describe the phenomena. But from here, firstly we have designer. Designer doing what? Designer is going to create an artifact. Artifact is going to stay, to be in its environment. So design is going to create the artifact. Artifact is going to serve the environment. And in the first place, before they do that, the designer must be able to understand the environment. Then the artifact eventually has to be able to survive in its environment. So in this case, the artifact will change the environment and will be constrained by the environment. But you can get many definitions. I think eventually, no matter what definitions you have, I think you will be able to arrive in this kind of a description. So I call this is an object of study of design. And then let's see what do we have any extremism or loss about it. So if we put it here, this is the object of study of design, which means that anything in design activities must be able to be described in this domain. So you pick up IoT, for example. Can we describe IoT in this framework? You pick up creativity. Can we describe creativity here? You pick up fixation. You pick up knowledge. You pick up knowledge retrieval. You talk about machine learning. Can we have a place in this framework? So this is what we do. So the first part we have, like this part, artifact environment, is what engineering subjects have been dealing with over the many years. Where we deal with engineering systems, like IoT systems, may be a part of it, because in this environment we can have human being in the environment, we can nature and the art and the built environment. So any artifact, this can be IoT system, can be any system. And this part is a human part. So eventually, what is the design that has to deal with the relationships between human and the material systems. The first part, any problem from our material world will go into our designer's mind. Then we through our rational process, we get a solution. Then the solution will go back to the environment. This is the first part. But in the second part, from a human perspective, so any work from here goes to human brain is a work. When we do work, there's a workload. Then some work we like, some work we don't like, so we have emotion. So then we have an emotion to respond about it. So eventually, we have two parts. The first part, like we have a reasoning process to solve a design problem. The second part, we have an emotional process. Like the design problem itself will give us all kinds of emotions. If we are dealing with a familiar work, maybe it's very easy for us. If we're dealing with a very challenging work, we feel stressed. If we are dealing with a big decision, life decision, we are going to be maybe in a very secure situation. So the first part we say in this reasoning part is a rational brain, and then the second part is emotional brain. So if you want to have a law or anything to deal with the design science, we have to have something to see about these two parts. We have to see something about the reasoning part, it's just another thing about the emotion. Then these two parts have to be put together, then we have a foundation for design science. Over the last 30 years, for the first part, for the reasoning part, we develop a logic of design. We call it design reasoning follows recursive logic, which is a nonlinear dynamics, which means that the design is a process in which design problem, design solution, and design knowledge will co-evolve in the same time. So the design problem will change the solution, solution will change the design problem, knowledge will emerge, it depends on what problem, depends on solution. The second one is that design creativity is related to designer's mental stress through an inverse U-shaped curve, which means that if our stress is too high or too low, we're not going to be very creative. The stress has to be in the middle. This is not my invention. It came from a psychologist, like Yerkes-Dawson law. Like if you go to psychology or management, there's a Yerkes-Dawson law. You see the performance, not as critical performance, is related to stress in this manner. But we change it to creativity. But we are engineers. When we say stress, first time when I saw the word stress, we came to what is stress? Stress is a force over area. We do stress analysis, right? That's stress, material stress. Then I say, what is the mental stress for human being? What is our stress? How do you quantify our stress? And so we have workload, which is a force. So what is area? Our mental capability. So we say this is stress. So our mental stress is a perceived workload. I did one word, perceived workload, because a workload depends on how you see it. Like for students, we give them the same design problem. Everybody will going to see it differently. So for example, we look at the cyber physics. Everybody will give different solutions. If I ask people define what is design, when I give this definition, I saw like the usually may not be correct. Everybody have different definitions. So first thing is the workload is perceived. Perceived based on what? based on each individual's knowledge, experience, reasoning, and your emotion. Because some words we have using too much, and then you don't like it anymore. And then what is what is mental capability? It has three parts. We have knowledge and the skills. Skills like reasoning or logic. Knowledge plus logic is rationality, or rational part. So how strong rationally we are, like this is a capability or rational capability. Then we have an emotion part. So emotion is like it's playing a weighting role from 0 to 1. If our emotion is 0, no matter how knowledgeable, how good our reasoning is, we are not capable. Our stress is going to be infinite. Only if our emotion is 1, then we can make full use of knowledge and the skills. Can it be possible to have a 1? So then you have to do meditation, you have to do many other things, like to practice yoga or other anything, like to make yourself in the state of peaceful heart, peaceful mind, and anything, so that you get a 1. So this is this part, like from my structural engineer background, so I get this formula for human stress. Then, what are the reasoning tools? Can we reason about those two things? Again, we have to reason about it. We have to have mathematics to represent all the entities and the relationships included in the activities. So after I spent about 10 years, and I derived this kind of mathematical formulation to represent an object. This is the structure of any object equals to the object itself plus the relationship from the object to the self. It's like systems. What's a system? System is the components together with the relationships between the components. What I added here is the self-relationship. With this one, then this definitely becomes a recursive. You can decompose it infinitely, and you can come back then to a single representation. With this one, we can represent this is the universe. How can we represent it? So this engineering system, then we can represent like this. If you add the human being there, the universe is going to be like this. Then with this one, we can have a structural representation, like a hierarchical representation, to do that. So in this way, we can represent any design, any systems. The reason we had to have this one is because in design is different from physics. In physics, in traditional math, we represent what are known. But in design creativity, we have to represent what's going to come, which we don't know, we cannot predict. So how can we represent what we don't know yet? So this one plays that role. Then we have this reasoning tool, this representation. Let's come back to what is design. So we said the design will have three parts: designer, prototype, and environment. So in the beginning, we had no design. Like right now, for example, we have environment only. When do we have the design? After my presentation, if you have a question, you you have a doubt about it, you may ask a question. So that is when there's a conflict. When what I'm seeing here is inconsistent with what you think, you thought, there's a conflict. So I have to give a solution, answer to address that problem. That is the product. When my answer goes to you, it becomes a part of the environment. So this is the design process. What is the design process? So design process is a process of environment evolution. So what do I see? So design comes from the environment, because in the beginning we didn't have a design. When we have a conflict, we have to design. So design will serve its environment, and eventually we're going to change the environment. I'm not going to give the detailed methodology about the process, but this one, then based on the mathematical tool I just presented, we were able to derive a design governing equation. It's like a differential equation for mechanics. It says a design evolution is governed by this formula, this equation. This is the synthesis. This is the evolution process. This is the synthesis process. Two processes working together. One stretch the design solution. One shrink the design solution. Eventually, we stay in somewhere. So this becomes the design process. It evolves like environment evolution process. So now let's come to what is the rational brain. So as we said, stress equals to perceived workload over the capability, human mental capability, which is knowledge and the skill. So those are three parts together is dealt with by our rational brain part. And based on this one, we have derived conditions that are necessary for creativity. So we say different formulation of a design problem. Initial conditions will be one of the necessary conditions for creativity. This comes to the workload. Kind of different formulation, different perception of the workload may lead to design creativity. And the second one is that extension of design knowledge may lead to creativity. For example, in our knowledge now we get the sensors, IoT. This one is a new piece of knowledge, a new piece of technology. So with this extension of our knowledge of our technologies, we may become creative. We can add that into the existing design. The third one is a different strategies of design decomposition. Like you think differently, you decompose the problem differently, you can get different solutions. So I feel that we derived those are the three necessary conditions for design creativity. So this comes knowledge, skills, and we don't have affect yet. So what is the affect? That's the emotion, right? How does emotion play in this process? So when we are emotional, what happens? Our perception will be changed. When we're emotional, we may get a panic. It's like Daniel Kahneman, he said we have the first two kinds of thinking: fast thinking and slow thinking. So this is will affect our knowledge and affect our skills. Because when we are too emotional, we cannot have our rational reasoning process anymore. So what does emotion do? Emotion changes those conditions. So then, how does emotional brain can the emotional brain be rationally creative? So rationally, our brain follows a kind of non-dynamic recursive process, which leaves three conditions for being creative: initial reformulation of initial conditions, the problem, the knowledge extension, and the skills. And the emotions comes to change, to help us to reformulate the initial conditions. Therefore, both together will lead us to different kinds of creative solutions or non-creative solutions. So this is how it will work. So with this one, then eventually we have to come back to the fourth component. How are we going to experiment, which is also emotional part? Over the last about 13 years, we started to study on emotional brain part, like the human cognitive and emotional part. This is my lab. We have this is skin conductancy. This is eye tracking. We have respiration, HRV. This is EEG. We have cameras, many things there for our lab. We try to study human human cognitive and emotional process. We started in 2004, and until 2014, we were able to publish the first journal paper. And then the research has gone through 4 stages. So the first stage, we try to test if it's possible to use EEG to study human design. So we did an experiment, very simple experiment. So after we did this pilot study, we see EEG can be used to study human design creativity, which is very complex compared to psychology research, cognitive research. In that experiment, we had 8-channel EEG system, but we didn't have very good data synchronization device to do that. So we had to do it very manually. We say start, then people start to press the button to do everything together. I had a few students doing that together to control the switch or the button. I said start. Everyone started at the same time. So the tasks are unstructured, very open-ended design tasks. The second stage, then based on the lessons we learned, we used the 14 channels of EEG system, and then we use different program, and we try to quantify that U-shaped curve. And then synchronization is still not good, but the program was still unstructured. And then the results were not very that excellent. So after that, we redesigned our experiment, and we added more control. We had more channels, 64 channels, and for these 2 stages, we were able to see how the stress will impact our design, our experiment itself. So then finally, in the stage 4, we were able to do it in a controlled way to study design. So we started to look into creativity. We designed a experiment, like a semi-controlled experiment to do that. So driving force for all this, for this evolution, is the first one is accuracy and the convenience of devices for data collection. When we design sensors to collect the data, so it has how accurate are our data are, and how convenient for us to use the devices to do that. So this is 2 things we have to consider for the evolution of those EEG systems from 8 channels to 64 channels. How are we going to do that? It's balance between accuracy and convenience. A second one is the level of control we have that can be added to design activities. Because design creativity, we said, has to have the freedom, has to be flexible, uncontrolled. If you control, then we cannot be creative. That is the problem for psychology. In psychological research, for the last half century, they made a very good progress in memory, attention, and many other things. But for creativity, they made almost no progress. One of the reasons is that they cannot control creativity. They cannot dictate when one can be creative, one cannot be creative. If you can do that, then you don't have the data cause effect, like a stimuli response relationship to study that. So if we want to give people flexibility, then we don't have a control of data. If we don't have a control of data, the data is unstructured. For science, we have to have structured data to get some meaningful results. So how can we deal with this conflict? This is the second driving force behind that. The third one is the different analysis technologies, like the machine learning or regression, traditional statistical analysis, all kinds of tools. Like how can we use different tools to do that? Can we use deep learning to do that? People say, right now we have deep learning. We can throw the unstructured data into the machine, and the machine will learn by itself. Is that true? I don't know. And I don't believe that we can really do that, but in order to find the science, we have to have some kind of quality control of the data, otherwise garbage in, garbage out. It's like yesterday, I think you really talk about the finite element analysis. 30 or 40 years ago, people talk about the finite element model. If you give in the bad model, you get the bad results. Now we talk about data IoT, talk about data mining, machine learning. What is the quality of the data? So those are the 3 factors we have been considering in designing our experiment. How are we going to, what kind of sensors do we have to choose? How are we going to put the sensor? What kind of design problems, engineering problems do we have to give to the subject so that we can get meaningful results? How are we going to analyze the data after the fact? I'm not going to go to the details of this experiment, these 4 stages. So the first experiment we did is that we found out that EEG can be used to study in design. We get a kind of a few meaningful results. So this was published in 2000 in the SME DTM conference, 6 years after we started our experiment. And from here, as you can see, this is how we put the sensors into the head. We just put the tape and then stick there. It's very ugly, and then only 8 channels. After that, the lessons we learned is that we have to purchase a EEG cap to make the installation process, setup process much faster. And then we increased the EEG channels to 14, and we divided our experimental room into control room and experimental room. And before we code, we do protocol analysis, we code it, and we decided not to code it. After that, we went into stage 2. Our experiment becomes more robust and the results are more reliable. And then we studied the relationship between mental effort and the mental stress during the conceptual design process, which was, this paper was published in CAD. That time, like I think it's in the special issue for next generation CAD systems. That was the first journal publications. So the purpose of that paper was trying to validate this U-shaped curve. We were not able to do that because we found out some subject may fall into this part, some other object may be here, and some others may be here. So when you do statistics, how do you know which is which? Usually when people don't do, if you throw this into machine learning program, they're going to put them all together. You don't get the meaningful results. So you have to be able, because no single person can cover the whole range. Because each person can be only part of it. How do we know which part is which part? We don't have a ground truth. How can we do that? How do we do the baseline? From there, again, we learned, like we have learned some lessons. So then we increased the EEG channels into 64 channels, and we bought a new system, Captive, to do synchronization, and then design task becomes more structured after that. So now you can see our system becomes more and more comprehensive, and then we have a structural design. We have 60 different design problems. The first design problem, we say, okay, first you read the problem, think about it, you draw it, then you evaluate it. Then you stop for a few seconds, start second problem, and third problem, because we assume that when you're dealing with different design problems, your thinking is still design thinking. So no matter what design problems is, because design problems is constantly redefining it. So we hope that these 6 problems will represent a larger design problems. In doing that, we were not able to identify the reasoning mode, but instead we found out our experiments can be heavily influenced by our stress, because each individual will have different perception on the difficulties of a problem. One problem is simple for one individual, but it's difficult for another one. So it's very hard to say how can you to put them together. So we did this one, and then after that we came to stage 4 to do a creativity. We started with this problem, give a subject this symbol. So the first part we say, just write down a title for this one. People say it's check mark. After that, then you say second stage, you say, ask the subject, you try to make a design solution that is as different as much as possible from what you saw. So we have these 2 parts. The first part is called the routine design, second part is called the creative design. Then we were able to compare them to look at how different the brain signals are, and then what is the difference inside the process. And right now we just finished an article about this one to see. In these 2 processes, we found out alpha wave in our brain is very significant for creative and non-creative activities. We are not going to discuss that in details. So those are the very theoretical part, and I didn't go into the details. If you are interested, you can also send me emails. We also have a workshop in August, so you can come to Montreal to discuss with us. We can have a training section to see how you're going to use this mathematical theoretical model to derive design phenomena about design activities, and how you're going to do experiments. Because right now, when we do design research, we don't just think. So first, step 1, we write down what phenomena do you want to interpret. You describe it in 1 paragraph. Then we use this theoretical model to derive the results based from these 2 hypotheses we proposed, get a theoretical model, and then we do experiments to validate the model. So it's like with traditional engineering science. First you derive equations, then you do experiments. So this is how we do design research now. Over these years, like people always ask me a question, like how can I buy those easy systems from 8 channels to 14 channels to 32 channels, 64 channels? It seems like I have an infinite amount of money. I want to buy whatever I want to buy. But design research is very challenging. How can we get the money to do that? So this comes to these applications for 2 reasons. Because from applications, I do a lot of industrial projects. Different industrial projects, as you can see here, we do algorithm design. We design 3 kinds of algorithms: finite element mesh generation, 3D sketch reconstruction, curve reconstruction, and we do product design. We do medical devices design for companies. We develop 2 products that are still being used by them. And then we do process design, like secure collaboration. We do quality management system. We do risk analysis of construction. We do human resource management, KPI. We do like a musician, cruise liner matching. We do organizational stress management. We do teaching and learning design, do many different things. People ask me, why do I do this? So many different things. Is it possible for us to do that? So I said there's a first reason we need the money to do the research that cannot be funded by government, like all those crazy research. So these industrial projects, each project will give me some surplus, 30%, 20% of surplus. I use this money to support the research that just presented. The government will never support that. Secondly, because we are trying to do what? To develop design science. When you want to develop design science, that means that we treat design as a generic phenomenon. If it's generic, what does it mean? It has to be able to deal with all kinds of design activities, no matter it's engineering design, it's organizational design, it's our own career design. Since all those are design problems, can we deal with all those different design problems? So that is why I take whatever design engineering projects coming to me, because I think most of 90% of engineering projects are design projects. So I said, no matter what, it just I'll do it. When I did that, for example, the first project I did in Concordia was a medical device design, signal process, in which I had no background. I was civil engineer. So I did it, and after that, I learned Fourier transform, wavelet transform, and I didn't expect I will be able to use it later. So this gives us this kind of motivation and the funding and the testing bed for the design research. So I'm going to summarize 3 recent applications. Recently, we are shifting to teaching and learning design. Why did we do that? Because firstly, this project just came to me. Secondly, you look at the way we are dealing with stress equals to perceived workload over mental capability. Capability is our each individual's ability. Right? What does education do? Education equips students with capabilities, knowledge, skills, and attributes. So this is natural to do this. And then it's natural. So first, this came to me firstly, about 3 years ago, aerospace companies from Montreal came to us, asked us to help them to build up a new aerospace engineering undergraduate program so that we will be able to create aerospace engineering students that can be used in 3 or 5 years after their graduation. Right now, it took 10 years for them to train a fresh undergraduate. So in doing this, so we have this model. We try to train knowledge, skills, and attributes so that they will be able to deal with the workload and has a right stress, so that we will try to maintain their mental stress in the middle. That is a 2 million research project. So it's for 5 years. We just finished the 3rd year. We have 2 more years to go. A second project we did was for another aerospace company. They do change management. It was very difficult for them. They tried many times. It wasn't successful. So they came to me, and I did this project with them. It's a change management. I told them it's a design problem. This is a change from one state to another state. So it's a design. It's a design problem. So I treat it as a design problem. And then I say, in order to implement the change, we have to manage stress. If our change is too big, it's too stressful for people to be involved, then change cannot happen. We have resistance, strong resistance. So we have to manage the change in such a way that every step will trigger reasonable stress among the people involved. Then we can make the change happen. So this is two parts. In change, we deal with capability, we deal with perceived workload. And throughout this process, in the beginning, they didn't believe we can do something, and then we designed a questionnaire based on this model, and then we give them like 10, 15 questions to each, to top manager to each one. They thought that in the beginning, they thought it was too simple. It's impossible we can get some meaningful results. But after that, in 2 days, we give back their results, and they were astonished. We predicted their current status, we predicted many things, so they were able to do it. And based on that one, we have this change management model, and what's the training, what is the culture, what is the emotion, what is the workload, how we deal with that. Then that project was about 1.2 million. And then the third project, which just was approved recently, it was an industrial project for another aerospace company in Montreal. What they do is that they want us to monitor the pilots' affective and the cognitive states while they're learning how to fly an airplane, so that we can do adaptive training to give them the proper materials at each step, so that they can train more effectively and efficiently. So those are the applications we have. So in summarize, what is the design science and how we address this problem? So we have object study dealing with the emotional and the rational brain, and we have these two hypotheses. The first one deals with the rational part, and the second one deals with the emotional part. Then we had this mathematical framework to represent design activities, and we have experiments to validate everything there. Based on this one, we were able to apply this to many companies and different industrial projects. I'm not going to talk about this one, this reflection. This concludes my presentation.
Thank you very much. As you already counted the hand, so Professor Albert's over there.
You decide who is going to.
Yes.
Okay.
Thank you very much for the brilliant presentation. You know my work as well. I work on the same direction since 20 years as well. Mm-hmm. And we do very similar things at the KIT, changing, for example, the learning formats and so on. But I have two questions. In our context in Germany, stress is a negative value, and the positive stress is after the model from Alexander von Kuhn, the flow. And I trained this in the flow direction. It's exactly what you say. Mm-hmm. So having flow motivates to be creative and successful. If you overload the people, then they get fear and say failure. And if you understress them, if it's too low, the workload, then they get lazy and they do nothing. And nothing is coming out. This is Alexander von Kuhn. But I think it's very similar to what you have mentioned.
Yeah, I appreciate your comments very much, because I was talking to a psychiatrist in Calgary. Like, we want to do research against stress. He didn't like the word stress. He said stress is negative. Yeah. It's for patients. We talk about engineers. They want to have something positive. I said maybe arousal or something. I said because this for engineers is a symbol. Like, so we call it stress. You can call it something different. It's a sigma. So sometimes we say it's a sigma. Whatever you call it. I think you can call it a flow. I think it's very good. It's a semantics. It's how people perceive the meaning of the word. I think it's a very good suggestion about it. We have always been thinking about what is a better word for this one. I haven't figured out yet.
I will send you one or two papers from Alexander von Kuhn. If you read it, you can clearly see what he.
Sure, definitely. Thank you so much.
My last question. I do also a lot of creativity research. Mm-hmm. And what is about the aspect of fantasy? We say that fantasy is a key thing. knowledge, skills, and fantasy.
Mhm.
Do you have also the explanation fantasy in your work?
Fantasy, like in the fantasy, when you have a fantasy, how did it happen? Like when you're sitting here, you are thinking about many things, imagining about things, right? So you have to have two things here. Firstly, you have a starting point, some information. Secondly, you have a process, a skill. You can call it the thinking process. The thinking may not be rational thinking. It's your rational thinking process. So
I think if you compare it, for example, Pablo Picasso, he has a clear mathematical model after all his pictures, but it is not rational what he said.
If I may interrupt, consider Escher.
Yeah.
The imagination so dominant that you cannot have a starting point. It's very good. So I apologize. You see, the midnight train arrived. Yes, please.
That's a fantasy. Like it depends on how you put it there. Like, you can put it as a workload. Depends on you see, like when you have fantasy, you start to think about something there. Right? Then there's a workload part. There's a part about the emotion part, because when you are fantasy about something, you feel excited. So there's an emotion involved. There's a workload involved. There is a thinking process involved. So fantasy is a combination of all of them, I think.
It is exactly defined in the neurology. But the key point, very good. I look after this fantasy because I claim that most engineering courses bring the fantasy out of our students, and that is a problem.
You're perfectly correct. I think for me, when I'm teaching a course like design methodology, so one of the objective is to make students to dream widely. Like this is one of my dream, my objectives, but this sometimes creates problems for me. Like students sometimes give me no evaluation for that. Like, so it's uncontrollable. Yeah.
It's very interesting that I cannot recall that, but somewhere I read that actually design starts with not conception, but with inception, which means that other things are coming to our mind. Very good, this one. That was a question I believe here.
Thank you very much, Professor Zeng, for your presentation. It was really very, very interesting. I'm also involved a little bit with this kind of study.
Please speak up a little bit because
designer. Yeah, sorry. So my question is, I think you are familiar with all the literature concerning this kind of things, of course. Probably you have read something from this professor of the University in Marseille, Nathalie Monardel. We studied in particular, the effect of creativity on designers, and I mean how to also try to improve, to teach creativity. That is a very controversial issue. And my question is about the impact of technologies, because I'm studying in particular in this period the impact of using some tools, in particular, for instance, for a designer, a CAD, in which way, because it's a very controversial issue, this kind of use can affect the creativity of the designer or can enhance the creativity of the designer. This is still something where scientists have different opinions, so I'm asking you which is yours.
This is a very interesting question, because when we look at what is the impact of design tools on our creativity, I don't think we can have a universal answer for this question, because it depends on each individual. As we said, the stress part, right? In order to have a creativity, to be creative, our stress is to be in the middle. Now, if our stress is in the very right-hand side, suddenly we get the technology to help us to release our stress. Then the technology will help us to be more creative. If we are already in the middle, the tool will increase our stress, then we are not going to be creative. For example, the sketch reconstruction project I did, that came from an engineer, a very old, last generation, even much older than me. So what he told us is that he will never use AutoCAD per engineer SolidWorks, because that tool prohibit him from being creative. And he wants to only sketch. But for younger generation, they were trained from university how to use AutoCAD, how to use these manuals, these things. You can be creative using these tools. So in this situation, then we had to develop a tool to bridge sketch and the 3D modeling. So this gives you example to see how the tool will have impact on our stress and will impact on people's creativity. The impact will happen in many ways. The impact of their knowledge, the impact on memory, impact on their skills. We published a paper studying the impact of sketch, the impact of 3D prototyping, and different tools on creativity. We derived the model without experiment. I think it's, what you are seeing is very interesting things that it's worthwhile to study that, but I don't think we can get a very universal conclusion about it that you can see varieties behind that. I don't know if I addressed your question. Yeah.
Professor Rudolph and Professor Vara.
Okay.
In your third last slide, you showed this stress equation. If you don't mind to just switch back.
This one?
Yeah. Do you see this equation more than a metaphor or as an equation?
I think you can call this.
This is the first part of my question.
Sure.
Then knowledge and skill seem to me capabilities you can acquire during your lifetime. Meanwhile, talent, for example, is a natural gift. And even though we claim that all humans are equal, in fact, we realize that they are not. So I am wondering whether you have a moving base in this equation, yeah, and that with the talent, I see students which somehow effortless go through the most difficult exams, while others need to be very.
What is the reference?
Yeah. And then, so I'm wondering whether you have all dominant factors in this equation, even if it's not an equation and only a metaphor.
That's a very good question. The first one, it is not. It's called a pseudo equation because at this moment, we don't have a very accurate equation. It's just a qualitative relationships, or you can call them metaphor. It just shows, okay, the stress will be in this kind of inverse proportional relationship with knowledge and skills. In which way, we don't know yet. Even how to quantify knowledge, how to quantify skills, we don't know yet. But affect, we are trying to quantify it. Even for affect, each individual is different. We have a different base. That comes to a second question, right? Some people are more talented, some others are less. Some people are more emotional, some people are more stable. This comes to the traits, psychological traits, like different kinds of personalities. This reminds me that, for example, when we look at the building, we have stone, we have concrete, we have steel. I think for each individual, we should have this kind of each individual have different type, we belong to different types of capability person. So I'm trying to do that. I recently hired a postdoc student who is from mechanical engineering doing stress analysis. So we try to build up the bridge between traditional stress analysis for materials to the stress analysis for human being, to see if there's anything like this. And hopefully we will be able to move a tiny step along the quantification to make it a real formula. I don't know how far we can go. Yes. Yeah. Yes.
I think this is very simple to answer. You can measure knowledge, skills in this model. What I use from Alexander is the factor of talent. As the factor for intelligence, for example, is below that. The person can only reach a level of knowledge if he has a talent and if he has intelligence. And he can only get a level of skills if he has talent and if he has knowledge, the intelligence. And therefore, this flow factor is always individual. It is depending on the person. For someone like me, for example, designing an automotive is gives me flow. It is no problem for me. It's challenge, but I can. If I take a young student and give him the same task, he has no chance to do it, and then he gets in stress and in fear. And this limits the creativity totally. And this is very good and very, you can clearly measure this, in my opinion. Absolutely.
Yes.
Let's take the question from Professor Riley, then Professor Gran, and then we go for the coffee break, 2 coffees.
Okay, how can you consider
Anyway,
the holistic design approach in following your theory? It came on my mind.
And first,
idea.
Mr. First.
The heuristic design approach, how can you consider it? In the,
Design approach.
yes, in the theory.
Oh, theory.
Heuristic.
Theoretic design approach.
Heuristic.
Heuristic design approach.
Yes.
Yeah.
So just an idea like it came on my
And there
mind.
is a serendipity,
Yeah.
emergence, sudden emergence.
Yeah, like a heuristic approach, like when we talk about the heuristics, I don't know how you define heuristics, because in algorithm, like in my understanding, heuristics is compared to algorithm. Because in algorithm you have you have a theoretical foundation, you can do it in the completeness, but heuristics come to ad hoc approach. Right? So when you dealing with a heuristic approach, you're using experience. So that is the knowledge part. Then the reasoning part, like you can use intuition. So the reasoning may not be the logical reasoning, it could be intuitive reasoning. I think this is how I say it. I don't know if it, yeah.
Yes, thank you for your talk. And I concur with Albert, on a couple of topics. But what I think is missing is that there should be an increase in willingness for designers, and the motivational aspects are also very important. In light of that, I was thinking your experimentations are in environments very much geared with contraptions, sensors, and all kinds of stuff. So I wonder, how realistic are your measurements? And did you ever try to use some form of little doses of psychedelics in order to get another result?
For the first part, you see the motivation part. We try to include in the affect. You feel very motivated, your affect can move closer to 1, hopefully. But if you're too much motivated, you go down to moving to 0. It depends. So for the second part, for the experiment part, how much control, what kind of control you can have, I don't know yet. There's ethics there, there's many other things there, I don't know yet. So we try to do as much as we can, but we have to make it realistic as we can. We move forward step by step. I don't know how far we can go. This is a very open-ended question. I can give you an open-ended answer.
Let's take the next question then, and the last one, because we would like to
concur with those opinions that this depends heavily on the individual. You know that Albert Einstein's brain was removed for his death, and it was alive. It was an article published in the journal, and the main difference was that there was high interconnection between both hemispheres. So this shows that there's hardware difference in the individual. So whether this creativity can be trained or not, but there is certainly a hardware difference between individuals.
Yeah, I think this is I read some research about separate brains research, like from MIT or somewhere. Like there's some patients, because of the accidents, become some born genes. The left and the right hand brains are separate; they cannot communicate. So they studied this one, like the emotion part or rational part. I think this comes to, like maybe Einstein is very, very well merged together. So the emotion and the rational part are very well coordinated. So we don't know for human how we can do that, but I'm trying to collaborate with a group in China. They are doing experiments on rats, like they're doing that, but they have very low level cognitive or emotional activities. But when we come to creativity, I don't know how we can do that for human beings. We are an engineering school. We are not medical school. I don't think I will ever be able to get ethics approval to do that kind of experiments. And
let's take this last
sure.
question because
Okay.
it is like cold coffee.
It's not really a question, it's just more of a comment in terminology. You were discussing, the loaded nature of the term stress, and industrial psychologists sometimes distinguish between eustress, which is that good stress that sort of causes you to achieve things, that feeling of being out of your comfort zone and so on, and distress, which is the negative, crushing stress that sort of limits creativity and productivity. So you just mentioned.
That's right. Yeah. Thank you for the comment, please. Yeah.
Thank you so much for the presentation.
Thank you.
Thank you. And ladies and gentlemen, please listen.